Hi everybody. We're continuing to talk about conic sections. Today we're going to focus on the ellipse. There are two screencasts that I've created that are related to the ellipse. What I'm hoping you will learn is, given an equation of an ellipse, I want you to be able to find the center, the vertices, the foci, and graph the ellipse. So let me show you, first of all, in our group of conic sections, what we're focusing on is the ellipse. And the ellipse looks like this. And the ellipse is kind of like an elongated circle. It can be either elongated along the horizontal axis or the vertical axis. The definition of an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points, which are called the foci, is constant. The center of an ellipse is the midpoint of the segment between the foci. I like this illustration from your textbook. It helps to explain what an ellipse actually looks like and how you would draw one. So if you drew two fixed points or held them firm on a piece of paper and attached a string to them, and then use that string to draw an ellipse or an oval, that's what it looks like. These 2 points are called the foci. Plural is foci, singular is focus. So those 2 points are fixed. The center is exactly between, it's the midpoint between these two segments. And the length of that string is constant. Here's what an ellipse looks like, whose major axis is the horizontal axis or the y-axis. So what we're going to focus on in this screencast are ellipses that have their center at the origin. Just like I did with the parabola and the circle, we're always going to start where we're not shifting it, translating it left or right. No H's and no K's. So we're saying, okay, let's make the center be the origin, and then let's learn about all of these different terms, the vertices, the foci, and etc. Okay, so here's an example of an ellipse whose major axis, and when we say major axis, we're saying the longer length. So for example, when we're looking at an ellipse, the ellipse is not a perfect circle. So the distance from here to here is longer than the distance from here to here. So since this distance is longer, we call this the major axis, and we call this the minor axis. So this major axis is horizontal. This major axis is along the x-axis. Now, what I want you to see from these formulas is, notice we have these new variables, A, B, and C. Now, notice A has to always be bigger than B. So A is bigger than B. And when the major axis is horizontal, that bigger number is under X. Down here, once again, this doesn't change with an ellipse. A is bigger than B. And notice A is under Y when the major axis is the vertical axis, is the y-axis. So that's one thing that you want to be paying attention to. Where is that A? Is A under X? Because remember, A is the bigger number. If it's under X, then the major axis is horizontal. It looks like this. And if the A is under Y, then we have the major axis being the vertical axis, being the y-axis. Let's look at a specific example. For the ellipse 9x squared plus 4y squared equals 36, find the vertices and the foci and then graph the ellipse. I don't know right off the bat which type of ellipse I have, if the major axis is horizontal or vertical. But I know I have to write my equation something like this. It has to be x squared over a squared plus y squared over b squared equals 1, or x squared over b squared plus y squared over a squared equals 1. But one common thing you'll notice is that the equation has to be set equal to 1, and this equation is set equal to 36. So what I'm going to have to do is divide every term in this equation by 36. When I do that, I end up with x squared over 4 plus y squared over 9 equals 1. Now, can you tell if this is going to have the major axis be horizontal or vertical? Well, 9 is bigger than 4, and 9 is under y, so our major axis is going to be vertical. Okay, so 9 has to be a squared, and 4 is b squared. So the next thing you want to notice is from the definition over here is that to find c, we know c squared is always equal to a squared minus b squared. So c squared is equal to a squared minus b squared. And I know a squared and I know b squared, so I'll substitute those into the equation, which means c squared is equal to 5, which means c is equal to the square root of 5. Okay, think about what I did, just a quick overview, right? First, I set that equation equal to 1. I determined if the bigger number was under x or under y. Then what I did is I found out what c was. Now I'm simply going to follow these directions to identify the vertices, the foci, and then graph the ellipse. So first of all, we have the vertices. The vertices are on the major axis. So that means from the center, which is 0, 0, I am going up the A units. So A, if you'll remember, oops, I forgot to show that to you, but A was equal to 3 and B was equal to 2. Hold on a minute. There it goes. So A, remember, is equal to 3 because A squared is 9. So A is 3 and B is 2. That's written right down here. Every time I go over here, this shows up and I want to make sure you see it. So A is equal to 3 and B is equal to 2. So when we're going to find the vertices on the major axis, we're starting at 0, 0, and then we're going up A. See this here? 0, A. Well, since A is 3, that vertex is going to be 0, 3. And the vertex on the major axis under here is 0, negative 3. Now the minor axis comes from B. B squared, if you'll remember, is 4, so B is 2. So we're going to go from the center to the left 2 and to the right 2. So those are the vertices on the minor axis. Next, we need the foci. The foci is also on the major axis. So we go up and down from the center, c units. C, remember, is the square root of 5. So the foci are at, so the foci have to go up and down c units. So the foci are at 0, negative square roots of 5, and 0, positive square root of 5. The x value doesn't change from the vertex, but the y value does. Now, what about graphing this equation? We're just going to fill in the parts. So the vertices are 0, 3, 0, negative 3. The foci are 0, square root of 5, and 0, negative square root of 5. And the minor vertices are negative 2, 0, and 2, 0, with our center at 0, 0. Okay, let's look at a different type of problem. Find an equation of an ellipse given that the vertices are negative 7, 0, and 7, 0, and the foci are at negative 3, 0, and 3, 0. Even though it's not required here, I'm going to start with a graph. And I want to graph the information that I was told. So I'm going to start with the vertices. So here are my vertices. And now I'm going to graph the foci. Now do you see where are these vertices? Where are the foci? Is the major axis horizontal or vertical? Well, in this example, it has to be a horizontal axis. The major axis has to be horizontal because that's where the foci and the vertices lie, right? So we're going to be looking at this equation where a squared, the bigger of those numbers, is under x squared, remember? So to find out those, so to find out what a squared and b squared and c squared are, you're just going to use what you know. Now remember that the vertices are a0 and negative a0. So a must be 7. So if a is 7, that means a squared is 49. And we also know c. We know c has to be 3. And that means c squared is equal to 9. Now we don't know the minor axis, but we know this equation that c squared is equal to a squared minus b squared. So we simply have to plug in the c squared that we know, which is 9, and plug in a squared, which we know is 49, and that means b squared has to be equal to 40. That's enough to draw or to write the equation. X squared over 49 plus y squared over 40 equals 1. If you want to know what this graph looks like, remember we're going to go up square roots of 40. Well, the square root of 40 is somewhere between 6 and 7. And we're going to go down the square root of 40, somewhere between negative 6 and negative 7. And then we'll just draw our smooth ellipse through those connecting points. Okay, that's all there is to it. I know this is a lot to know and a lot to memorize. Make sure you take your time with these screencasts. Watch them several times if you need to.